Hey everyone, and thanks for listening to another episode of DIB Innovators. Today I'm speaking with Shane Arnott, Senior Vice President, Programs and Engineering at Anduril Industries. Shane, so excited for you to join me today. Thanks.
Yeah, great to be with you, Dave.
Obviously, Anduril is like one of the new titans in the industry and defense tech, so it's super fun for this opportunity. But let's start to shape this a little bit. Start with your, career path, a little bit of how it shapes, what you're building, how you build. But to frame it, you're really Boeing. You spent time at Boeing, first non-American senior technical fellow. And for those that don't know, it's one of the most selective technical leadership roles, and especially at a big company, a prime like Boeing. What did it take, as you rolled up to earn that distinction in defense tech?
Yeah, so I was with Boeing for a couple of decades and really spent a lot of my time pretty relentlessly just kind of going after the biggest challenges. And, that led me to Phantom Works, which was kind of where I thought the most interesting projects were and certainly where all the cool kids were, pre-Anduril. That's where everyone went. And I mean, Dave, you know that because you're a skunk from
Yep.
Lockheed, right?
Yep. Absolutely.
So yeah, basically, but to get into that club, I had to do something unique. So I was a vanilla software engineer like everyone coming out of university. So I picked a specialty, which was simulation. So 30 years ago, that was kind of fairly niche technology. And a couple of things kind of threaded to where I am today. So one was using simulation for warfare modeling. So I was involved in a lot of wargaming centers doing, force on force type stuff where you could bring in dozens or even hundreds of people and do big, theater fights. And over time, being able to teach AI to fight against a Raptor driver like yourself and exercise that. So the AI to be able to work against simulated sensors and behave like a human would, or a group of humans in a bridge of an Aegis class vessel or something like that, defending against some cruise missiles, etc. That actually became then a through line to what people call autonomy today. Like it was actually a pretty straight shot to go from the computer doing all this behavior then to robots doing stuff. So that was kind of one through line. And then the other one was Boeing was pushing into using simulation to go through the life cycle, if you will. So Boeing had this thing called the Diamond, and the Diamond was the systems, engineering V, if you will, with a digital reflection of that through the life cycle. So a digital twin is people kind of buzzword nowadays. So going from design through to development, through production, and having a thread through all that. So I was a big player, if you will, in forming that back in the day for Phantom Works. And that led me then into programmatics, running programs like the MQ-28 and other kind of fun stuff, which was, precursor to CCA, those types of things. So through all of that, I then, I guess, did enough right things in a row to then get considered for the fellowship. Like you say, it was kind of insane. Like Boeing, give or take, has about 50,000 engineers. So the senior tech fellow is like the top 40 engineers out of 50,000, right? So it was an incredible honor to get elevated to that level. And as a result, it was just epic experience. I got to then work at the corporate level across both commercial and defense and kind of think big thoughts about, future technology and stuff like that, along with a bunch of other folks of different skill sets. I was kind of the simulation analytics autonomy guy alongside, stress, propulsion, people like that. So yeah, just an amazing experience.
Well done. Those are pretty good odds. You need to come. I'm in Vegas right now. You can come join. Except yours is on skill, so not gambling. That is really cool. Well then, you were Boeing. You're king of the castle there, and now you jump over to Anduril. So, traditional defense. Some call it the new defense tech. What really attracted you to Anduril, and then what fundamentally changes? I think the unique thing is, primes are they're getting requirements, they're getting, certain type of IRAD funding and different funding that drive development. Andrew all of a sudden jumped over to, private capital. What fundamentally changes with that shift?
Yeah, it was kind of wild. So I've been with Anduril, it's about 5 years now. And I want to say I was employee 300. So it's kind of funny you saying, oh, Anduril, the Titan. And some people call us like a neo prime. It's kind of weird because like today we're, 7,000 people. It's just kind of going berserk, which is great. But, it's not where it started. Yeah, look, I think the hook was some things are different, some things are the same. So like the fundamentals of building, engineering's engineering. So, is Anduril doing something fundamentally different? Not really. I mean, there's kind of good practices and the approaches and that type of things in just kind of good practice engineering. Certainly, we bring a software first type thinking where the primes bring a systems first. It's kind of different, the iteration approach, that type of thing. Biggest change was really the risk posture. And you kind of think about engineering. Engineering's really like applied science to a problem within a risk management framework. They're really the two things that make engineering a thing, right? So when you completely change one half of that, and that's really the big achievement of the founders here, and that's kind of what attracted me, that they've kind of created this environment of the risk tolerance is like just the dial is just the other side, right, to my previous experience. And what that enables is then an engineer company, right? So short of the obvious things of, keeping people safe, but, otherwise we can go as fast as we want to go to get things done. Now, within the commercial framework, like we're spending our own money, but the approach of the risk tolerance being through the roof, but then also being able to raise money in the open market, pick the problems that we want to work on without waiting for the requirements, to your point. And then we've kind of got some freedom because we don't have a bunch of requirements that were set by some desk officer or some study that was done that wasn't justified on why the number's this versus that, which requirements are hard requirements, which ones are desirements, all that type of stuff. So it just becomes this incredible environment. So that was like super attractive. So when the guys were pitching to me, hey, you should come and have a crack at this crazy, defense tech startup, which at the time, to your point, I was in an incredibly comfortable position at Boeing. It was just very attractive, and also knowing, where the threat was heading. And a lot of that's now evident, less so in the public, 5 years ago, but I just didn't see the traditional systems. And it's not just, my former employer, it was kind of the whole system and everyone that grew up in that. So all the primes, but no one was really gearing up for that war footing that we had to flip to in order to be ready, because, China's good and they're better in some areas and we're playing catch up, and we kind of just need to change the mindset. Anduril's just one piece of that puzzle, if you will, for America and the West. But to be a part of that was, it was too good an offer to refuse. So here I am.
Yeah, and at work, I still remember, as a Lockheed, there was a DARPA program that was dealing with like small kind of, I forget the program name. I'm sure you know. They just shut it down. But to create some sort of like drone that could leave from a fighter and maybe shoot a weapon or something like that.
LCAT program, was it LCAT, LKitten, something?
I think so. And then all of a sudden, we see, you know, people are developing, like Ghost Bat, or, the things are coming out. I was like, holy cow, no one waited for a requirement because that was not a requirement. And this new capability just shows up and now it's being integrated. And so it's fascinating watching that.
But it's kind of what happens in every other industry in the world. People raise money, they take guesses, based on judgment on what the new product should be. Like, the old iPhone example, no one wrote requirements for that, but everyone's got one and they're super awesome, right? So why is warfare any different? Like it evolved to this weird space. It wasn't the case in World War II, etc. We were solving problems and you're going against the problem, a user need. You could, attack it a bunch of different ways. But somehow we got into this space where it was super rigid. You were following, this needs to be this color, shade green, for good or for bad, indifferent. It's like, well, why? Why is that the case, as opposed to what's the warfighting outcome? What's the problem we're solving? What's the threat that we're trying to knock over here? And just having that as a focus. So that's incredibly freeing to get after that early and then show and not tell, if you will. So we can turn up to a conversation with a customer and go, hey, here's the thing, like it's working. Is this mostly what you want? And that's kind of then the iPhone example where there's something there that's in your hands that then shapes, and then it's a shorter distance to actually get something in the field. So that's a big part of the thesis and seems to be working so far.
Oh, I mean, you guys have completely disrupted or been on the front edge of disrupting acquisition. I guess it's natural. You respond right to your, whoever's buying your thing, the customer, if you will. You respond to how they behave. Our defense acquisition process is kind of slow. So this has been great watching you guys just, help disrupt this. And because now the title, I mean, there wasn't much private capital available for, defense tech. Did you guys have trouble raising money? At 300, I think you were probably already going, but was there trouble, or did you guys actually feel like you could get the capital raised appropriately?
Yeah, I mean, this was deeply unpopular. You got to remember that, and
Yeah.
even in the early days, so there was a couple of raises which were touch and go, and I won't go into a ton of detail,
Yeah.
but to your point, it's kind of it's a little bit weird, I got to say, because we've been swimming against the tide, at least and I've just been part of the last 5 years of the journey, the founders from the beginning, but the tide shifted. We had SecDef here literally, a month ago or something. And he basically gave this speech and he went through, hey, here's how we're going to roll as the Department of War and how we're going to respond to China, Russia, etc. And then at the end of it, he goes, oh, I just gave the Anduril thesis. And it's like, yeah. So it is this amazing time because when I started, there was a bunch of people kind of doing the same thing, if you will. There was a company called Rebellion. So, Anduril's a Lord of the Rings play. I'm a Star Wars guy, so I kind of liked Rebellion. They're nothing now. Shield and a bunch of others, and we're kind of the only one that's left that can really, move the needle, if you will. We're at enough scale financially, workforce, we're working on the big problems now. So, but that said, to your point, we've kind of opened up a rift, if you will, a vein for a lot of other folks to follow. And that's kind of what's needed, like the industry needed to be shaken up. The fact that we're a vehicle for that is goodness. Because if we kept on the path that we were on, then I'm talking about the West here, there was no win scenario, right? So I think this pivot's good. If anything, it probably should have happened a few years back. But at least, the tide has changed. Everyone's leaning into it. There's a bunch of, follow-on Anduril, equivalents, defense tech companies, I should say, doing some good stuff, right? So I think I feel a lot better about that than I did before I joined. And, seeing our way of life continuing as the West, I think is in a lot better shape because of it. So.
Absolutely. Well, let's pivot now to, I think, a big debate in defense tech, and that's scale. So, I've heard the critique. Anduril ships great prototypes, but scaling production is the real test. You've been on the side of scaling production. So from your experience running major program, is there anything valid in that concern?
Yeah, I mean, this is the test, right? So everything everyone's saying is correct. The bit that's maybe been missing and maybe not as evident is it's definitely been part of the thesis for Anduril for the manufacturing. So we very explicitly kind of build our systems for scaling. So that's a big part of the process for what it's worth. That like when we're going through the design reviews, if the engineer comes in and goes, oh, I've got this super awesome engine and it's going to be ready in 2035, it's like, no, that's not going to work. Or some other magic and, unobtainium, whatever. It's very much this focus of, what is something that we can get. We still may have a vision out, to the hypersonic super magical thing, out in 2035. But, what are the stepping stones to kind of get there? How do we kind of get something in theater quickly? So one that gets you into certain technologies that need to be real. And then also, how do we pick technologies that can scale to the manufacturing point? So yeah, as a big aerospace guy, that was a big part of just the DNA. And this is something the primes do very well. Like they're actually good machines making machines. Boeing in particular, if you've ever been to Everett, it's pretty impressive, right? Now, that said, there's a lot of really high-end technology and relative, numbers of things getting built in an aerospace sense that are big. When you flip that to the autonomy and the attritable and the expendable kind of side, your orders of magnitude go up 1, 2, 3 orders of magnitude from, a lot of 787s that you need to go build. So the manufacturing technology needs to pivot probably more towards the industries that are, orient to that. And so automotive's a big thing. So while I'm a crusty aerospace guy and I love my big expensive robots and stuff like that, a bunch of my cohort at the, at the level that go and build these things that you see on YouTube, they're, Tesla guys and they're big production types. So we very purposely, like in design of our cruise missiles, like the Barracuda, if you've seen that, that thing gets through a process that's like extruding bathtubs. So if you've seen the body of the missile,
Yep.
it's a square. The way we make the square is it's pressed metal, and And it's stuff like that for the approach on how to get to scale. So we do have programs. Ghost Shark's one that's obviously close to my heart. You know, we're production scaling that thing. We've got factories that if you walk the floor of that thing, you would see kind of pieces of the prime, you know, production systems, some of the, you know, the safety systems, the flow management, but done kind of aerospace meets automotive in order to hit those high scale. And then we've got a massive investment. So of all the money we've raised, the arsenal that we're building in Ohio, that's going to be like 5 million square feet of production space. It's insane, right? But what's that going to look like? It's probably going to look more like an automotive production system, if you will, in order to hit the scale that we need to for certainly at the weapons, at the expendable level, and then the attritables for things like Fury, Ghost Shark, that type of thing. So
Yeah, I think that's interesting, the car side, because you're right. I'll use F-35. We can use, the F-15, Eagle 2 or whatever they're calling it, the new F-15, that Boeing's rolling out. Those aren't hundreds of thousands or even millions. And that's where we're going. So no one's really, I guess, in one perspective, no one's ever scaled to where it appears, the customer wants to go, which is by a lot, which is great for our warfighter. But
yeah, I mean, you look at F-35, right? I mean, that is true engineering art. There is a piece of titanium that's at the core of that thing that, comes from the fjords in, Russia or whatever, and then they got to machine the crap out of it. That in by itself, like the lead time on that's just insane. So all these things, super cool. As an engineer, it's super cool. But if you've got, a similar thing for like a lot of the torpedoes that's, we operate Mark 48, stuff like that. A whole heap of these parts have 18, 24-month lead times. Well, if the balloon goes up, I don't know, do we have 24 months to wait? Like this is kind of crazy, right? So we spend a lot of time, focusing on that. And yeah, so people can have all the opinions that they want. I mean, it's certainly where we're putting a ton of our points calorie-wise on making sure we're building those, not the one-off prototypes to have the cool videos. Like we do have the cool videos, but they are replicatable. We can build them at scale. We do have a number of examples of that. But I think, the haters are going to hate, right? So it is what it is.
Well, everyone loves to focus on one thing they can hate together, and it's usually the thing on top.
1000%.
Well, Ghost Shark, it went pretty quick. So maybe a quick overview for those who don't know, what is Ghost Shark? And then it went concept to production in like under 3 years, very quickly. What did you do to break that process to move fast?
Yeah, so Ghost Shark's an extra large autonomous underwater vehicle, so a big robotic submarine, and basically has a payload bay about the size of a 40-foot Connex box in the middle, of which you can imagine what you'd put in a 40-foot Connex box that can go anywhere on the planet. So leave that to the listeners, if you will. So this was something where there was a similar program in the US. It was called the ORCA program with the US Navy, and we all kind of acknowledged this was a very important capability to the fight. And this is kind of the conversation we have at the C-suite and the senior leadership level at Anduril. And we're just like, hey, this is really needed because you look at every other domain, it's either contested or denied. And I'm talking about China here, space, air, surface, pretty much denied. And China's exercising the same tactics that we do against them, the anti-access, area denial type stuff, right? Last door that's left open is subsea. Except a lot of the subsea assets are these incredibly complex, incredibly expensive, very, very capable, but in very small numbers. And if you've seen a map lately, the Pacific's a really big bathtub. So I don't know, probably be a good idea to have a bunch of robots that would work alongside the man thing. So that was kind of thesis. So we actually shopped this idea around as both with the USN, with Royal Navy and the Australian Navy. Australian Navy kind of bit on it. They were the ones that kind of said, yeah, let's do it. Because we said we were going to do this. This was just something we had conviction we should go do. Now, the Ghost Shark program, yeah, started a bit over 3 years ago. It wasn't just because of my accent that, we went to Australia, but it kind of helped because I'd done the Ghost Bat program before that. So Navy wanted to one-up the Air Force, with a thing. Who knows why they're both called Ghost? Don't ask me that. But anyway, with Ghost Shark, and this sounds a little bit trite, but there was probably two things. One is there was true partnership with the government, and that mechanized because we put in half the money and they put in half the money. So that changed the power dynamic completely. So when there was a little bit of the typical, and I've been doing this for a while, typical dynamic with the customer is a little bit master slave, right? It's like, you will do my thing, and here's the shopping list of stuff that you're going to do. Whereas the second part of the puzzle here is they just had a problem they needed to solve. So there was certain things I can't talk about in open line, but, certain actions that need to be taken on certain parts of the planet, in the ocean and coastline and close to that. And it was like, you guys tell us how to get this done, because, Australia is a massive country, as big as the continental United States. It's got 10% of the population, just does not have the people to staff a lot of the things that need to be put out in the field. And they're in the neighborhood of the bad guy, right? And plus, the United States was asking Australia to kind of play a bigger role, fast forward AUKUS is a thing, etc. So there was very much this, we had a lot of freedom to what was the shape of this thing, like literally the shape, and how far and the combinations, also even the payloads that we were putting into it. There was very much a dialogue on that. That approach as well, that we were able to get in the water within, basically 12 months of starting that contract, when the US program had, give or take, taken almost a decade to get to a similar point, was kind of insane. And then we're able to complete that program, and we got the development program, and we transitioned to the program of record last year, which was a $1.7 billion Australian Pacific peso, program. So about $1 billion US. But that will actually, the Royal Australian Navy will be the biggest subsea robot owners, capability folks in the world as a result of that program. Now we're seeking to, have Ghost Shark become Golden Shark, here in the US for the USN, et cetera, obviously. But, and there's, discussions there, but kind of an incredible journey. And also, as you know, I was an air guy, so to learn subsea was kind of wild in itself, but an amazing journey for sure.
Is there anything, you look at Australia's approach that other, friendly allied nations could learn in this type of partnership?
Yeah, it's everything I kind of said, and having the courage to kind of pick a winner and just have a crack at it. Like, it was a moderate amount of money. It was a $100 million development program, 50 million on each side. So we're not talking billions of dollars. So having, a couple of bets, you're in Vegas, having a measured bet and seeing if you're going to win or you're going to lose, and maybe playing a couple of those. But the fact that, like, Australia, I don't think had designed an original equipment submarine ever, to my knowledge, nothing of that kind of capability, but was able to kind of marshal that, work with us, build a supply chain to make sure we were ready to scale. And in fact, that was actually a big part beyond just the technology development, going back to the manufacturing. We did a lot of investment in the supply chain to get them ready, extra machining, going in there, helping them with their quality systems, things like that. Because the Australian government has certain expectation of local content, etc. So yeah, that's been a big part of the story, and kind of why it went, from development program to program of record, because it was a bet that paid off. And now, it's going to be a significant capability for that nation, which, we're pretty proud about.
Well, it's amazing. Well, the other thing I want to just double click on is $100 million sounds like a lot, but to develop something off the back of a napkin to have it run a program of record is not that expensive. Compared to some of our big program of records in the US. That seems pretty damn efficient.
Yeah, no, it was wild. And the partnership thing, just to click on that a bit more, it kind of changed, the design reviews. Like, with your background, like, you'd turn up to these design reviews, and either they were caustic or they were theater. Like, they weren't real. So in this partnership thing where we both put in 50-50, we literally turned up to some of these design reviews and we're like, hey, we don't know how to solve this. We've tried 3 things, not working. And marked ourselves as such. And we would have folks from the government, one of them that we've talked about publicly rather is the biofouling. So one of the things with the ocean is the ocean wants to eat everything that's non-organic in it, right? Environment is worse than the threat. The environment is a big part of the threat for these systems, right? And the Asia Pacific, there is no hungrier ocean than the Pacific Ocean, right? So a lot of the UUVs that have been great in the North Atlantic, where it's nice and cold, there's not too many things living in it, their guys would use it in Australia or in, Singapore or whatever, and they would get caked within weeks and just become useless. So it turns out the science technology organization like the DARPA in Australia spent a lot of time figuring this stuff out and, having facilities all up and down the Asia Pacific in various places. We could put different materials in and figure out how to make sure this thing could survive because this big thing lasts at sea for months at a time. Like, it's kind of wild. So how do we make sure the thing doesn't get biofouled? And that was a great example where we literally turned up and were like, hey, this is not looking good. We've got some problems with the control surfaces, the biofouling then impacts the ability for it to, get barnacles, whatever on it. And they would just step up and say, hey, yeah, we can do that. They would lean in with some of their research programs that then landed on the vehicle. So just having that mindset, and I think this is kind of the war footing where everyone's in, as opposed to I'm the boss, I'm the master.
You're not showing up to get graded. We're joining together to solve a problem.
Yeah, it's a lot. Like, I think it was made possible. Australia is a small country, so there's not that many people at the dance, right? So if you can kind of get enough of the right people aligned that this is a good idea, and we had that with the chief scientist, we had that with the chief of Navy, blah, 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 and they kind of helped, knock people out of the usual kind of mindset. In bigger countries where there's a broader church, I won't say which ones, sometimes that's a bit more difficult, but as we, slide further and further towards this getting realer and realer, which it's real, we do need to change that mindset. And I think we are seeing that on programs like Fury. We're definitely seeing it with USAF, but it could be more, if you will, across the other surfaces here in the US and certainly with other countries where they've got that smaller set of decision makers. They could follow the Australian approach where it's just less people. You need to get aligned to get the alignment and the adjustment, if you will, on the headset, and then just go after the problem and see if it works, see if it doesn't, but everyone rowing in the same boat in the same direction.
What a great story. I mean, yeah, we ought to take, hopefully they are, but that resonates big time. Let's zoom over to look at like the technical decisions behind some of these programs. When you're developing something like an autonomous submarine, how do you determine the right level autonomy versus what's too much? Like, how does that play into your calculus as you're designing and going through prototyping?
Yeah. It's usually the big question for autonomy. For subsea, super easy. Because guess what? Communications is super bad. There is, you are GNSS denied your whole mission, except when you're on the surface and, you're a bad submarine if you're spending a lot of time on the surface, right? Communications is horrible. So what it means, and I've kind of said this before, subsea is the masterclass when it comes to autonomy. Because again, you're at depth. You can't talk to these things apart from, sporadic opportunities. Positioning's difficult, so you've got a lot of uncertainty as a result. Vast majority of the subsea, the bathymetry, we've got no idea about as humans. It's kind of wild. Like, when you get into this space, even in the super secret kind of world, like 70% of the planet, we've got guesses on what we think the terrain looks like, as opposed to the air domain where we know down to the, millimeter where everything is and we can image it, pretty much every day, every hour or whatever. Subsea, it's wild. So as a result, you got to deal with a lot of uncertainty. You can't rely on the crutch, if you will, of RF communications or SATCOM communications, both for your positioning, nav, comms, the whole thing. So that was an easy one where we just had to suck it up and go, okay, we need to get really good at this and deal with these massive uncertainties, get some magic around how we get disciplining from a nav perspective in interesting ways based on the sensors and stuff like that, and just deal with that we're just not going to be talking to this thing very often. It's going to be very sporadic, days at a time before a check-in, or even longer if we needed to. And how do you think about then the safety cases, the regulatory part of that? There's a bunch of things around that we kind of cracked the code on as part of that program. So it was very cool from an engineering challenge standpoint.
That's fantastic. So we go like now to maybe another layer. So human versus the AI boundary until Musk gets his neural link. You guys just fielded your mixed reality system with the Army. Soldiers are commanding drones using kind of heads up displays. Where do you get, how do you see, it doesn't have to be exactly line, but human decision making end and AI begin? Like, how do you think about that?
Yeah, look, I think this is one of the grand problems that we've got in front of us. And if anyone tells you they've got an answer, they're lying. So I don't think anyone really knows. So there's definitely, some basic things like the laws of armed conflicts, where you need a thumbprint on the trigger for kinetic action and affirmative response, such that you can trace it back to a human for, all the legal reasons and that type of thing. But everything else and how much then contributes to a kinetic action. We've had autonomous weapon systems like Aegis, when that goes into protection mode, you press the button, you kind of step back and you pray, right? And hope that thing kind of does ship defense in the right way. So there's kind of this big pendulum, if you will. As engineers, our job is to make sure we've kind of got interlocks at certain levels of the involvement and the sharpness of the tip of the spear that you're getting to for an action, if you will. And then what we believe is that that will change depending on rules of engagement and also probably phase of operations and kind of where that would be. But to enable those interlocks the same way you would on launching a AIM-120 or something like that, there's a bunch of tech that's there to make sure that that's safety and assured. So we're building all that in. So there's the checks and balances that they're done in a high assurance kind of way. And then a lot of it's just going to be working with the customer. Eagle Eye's kind of epic, on what that could unlock. But a lot of it's really going to come down to getting out in the field, having a look at what that looks like for coordinating strikes, just coordinating troop movements. There's just a bunch of things that are going to come from that to explore where that human AI interface and handover is, and then kind of what good's going to look like. So I don't think there is any grand thesis other than we need those checks and balances from a code and hardware standpoint. And then we'll figure it out through actually using it with the customer and get the feedback from them.
Yeah, I think the other one, just to follow on, the ability for software to rapidly change and quickly put in software in the field. When you see something, you don't have to wait for a whole new prototype, and you can, quickly change it as you find where those gates are and continue to move through it. So
Yeah, and that's our DNA, right? So that is one thing that is fairly different. So the whole software cycle, we changing code and pushing updates to some of our counter intrusion, so our protective, whether it's the towers on the southern border or counter UAS systems that are fielded in pretty much every fort around the world. There'll be strikes on those air bases, and we'll push, daily, updates to models or code as needed. So there's a lot that sits around that, if you will, to do that. But that's the ethos that we have. And then beyond that, then the ability to kind of change up, hardware sensors and things like that. So that's less daily. It's probably more monthly. But then also to have overall iterations of the overall system, be in the order of, a year or two. And we, on the Go Shark program, that's called evergreening, where we literally kind of reinvent the submarine every 12 to 18 months. So new battery technology is probably an obvious one where there's just a gazillion dollars getting spent on batteries. It's an electric submarine. These batteries come out with more capacity. You buy those batteries later. Magically, the capacity goes straight to your range. Customer just gets more range, basically for free, right? But you need a whole kind of engineering infrastructure, the way that you verify, the way you accept with the customer. That all does need to pivot because we're just not used to that. Like, as you know, go build a thing, take 10, 20 years to do it, go through IOC, FOC, then give it to the warfighter, and you're already a decade out of date, right? So there's a bunch in the non-technical side of it, just the process piece and how the customer acceptance piece that needs to pivot with that. And they're probably some of the bigger achievements that we've done beyond just the technology. It's kind of the regulatory piece of it, some of the business model stuff as well. But the non-technical challenges are just as big a deal in fielding stuff quickly as the tech. So
yeah, that's perfect. A little bit on innovation. So you've led, multinational teams at Phantom Works, you're now at Anduril. What's the hardest part of innovation that really doesn't have to do with technology at all?
yeah, the international stuff, certainly when you've got, even just across the AUKUS countries, right? Like, we're separated by a common language. Although a bunch of people here still can't understand me, even though I live in California. But it's hard to shake the Australian accent. But culturally, there's just kind of different things, and particularly humans under pressure react very differently. And that really comes out like development programs are kind of pressure cookers, and they're pressure cookers that don't let off for multiple years, particularly at Anduril, right, where we compress everything. So having a objective system that you then, define the performance of the vehicle, you have objective ways to determine goodness, and you kind of get that in place early. One thing that's nice is the way that we count and do math is universal. And that kind of overrides, emotional, cultural, that type of thing. So we become that is part of it where we have a fairly rigid approach that everything that we say is going to be the key performance parameters for a system are all measurable. And then we lay out very clearly, here's the test and evaluation kind of approaches that we're going to use, surrogates, hiddles through to, the objective systems, that type of thing. It becomes very straightforward then at wherever you're from, that you've built the thing, it's working or it's not working. And you can have the Brits who are very polite and, very modest versus, the Californians that are going to tell you that they're fighter pilots and, and they're going to tell you that in the first 30 seconds, et cetera. And how do you balance all that out, along with the pain in the ass Australians who, are just doing what they do. So trying to get maths be the universal piece and then allow people to just kind of do what they do. And that was probably the biggest learning. And certainly I got that out of, I ran the International Phantom Works where I had people from 6 different countries. A lot of them were English, not first language countries, Saudi Arabia, Japan, other places like that. So how to boil it down to allow engineers to engineer and get the best out of everyone. And there's kind of some tricks to the trade, but numbers help.
Yeah, I think that's a great perspective. 'Cause it is people. They're the magic sauce, but they're also can be the biggest implementer. And I don't appreciate your comment about fighter pilots. 'Cause how do you know someone's a fighter pilot? I'll tell you.
Yep. Case in point.
I did, by the way, I did not tell you I was a fighter pilot.
That's true. I brought it up. That's fair. Yeah.
But I would have if you let me. That's great. What do you think is the most important technical problem in defense that not enough people are working on or worried about?
Yeah, I think we've hit on it. It's the manufacturing and the scaling. So we do need to be careful. To your point, the criticism that's leveled at us is leveled at a lot of these other companies that are
Sure.
coming up, which is innovation theater. Innovation theater is encouraged by the venture capital community because they really love videos. That is not necessarily what we need, like if you're mission focused, and it really is that scaling thing. So a lot of the time we'll talk to these companies, we'll go in, we'll partner with them or whatever, and it is unclear that they're really thinking about the scale problem. And whether they're then figuring it out for themselves, they're not necessarily figuring it out for the rest of the supply chain. There'll be this, hey, my buddy at MIT's got this super awesome actuator company. It's great. How many have they built? 4. Okay, so how are you going to get to 4 million actuators? Like, what's the path? What are you doing to help them, not just yourself, type thing? So I harbor concerns there that everyone's kind of really dialed into that. And also the fact that we're blending things from other places. So aerospace got to a certain way. You go to Airbus or a Lockheed or a Boeing factory, it all looks the same. And they talk about digital twins and all that kind of stuff. But again, that is fit for purpose for a certain number of things. You're only going to build so many NGADs, right? But when you're building CCAs, it just needs to be different thinking. So there's a start, there's companies like Hadrian out there that are these, new thinking machine shops or manufacturing capes. There just needs to be a lot more of that in my mind, to your earlier point. So
Yeah. Well, you're right. I mean, the venture, you bring up a good point, is, you're a founder, you're creating new capability. You want to show that prototype and then get acquired. So there's motivation of founders. I'm not worried about all the, downrange effects of scale. That's why someone buys me. They go solve that. So it is an interesting conundrum there.
yeah, and and acquisitions kind of happen, you get it, and then you're like, oh, well, how do I replicate this? Yeah, there's like 2 dudes who know how to do this, bend this composite, and they've just left with a bunch of, bag of money because we've just bought them or whatever. And that kind of happens, right? So I think that's still a systemic issue that we've got, and particularly as this new wave of kind of folks come in, I think it is understated how difficult that problem is to solve.
Yeah, absolutely. All right, lightning round, 60 seconds ish, 90 seconds, whatever it is. Just be raw. Let me have it. Quick hits. And if we've already you covered it, you can just say covered it, but just give me a high level if that's what it links to. So we got 5 questions.
Cool. What can go wrong? Let's go.
Biggest myth or misconception about selling to the DoD or DOW now?
That they're bound to the process and they want you to kind of jump through hoops. I think everyone who uses the uniform is focused on kind of getting something out to their sisters and brothers in the field. So everyone wants to get to yes. You just got to lean in and kind of help them get to yes. And sometimes that includes doing their job for them a little bit and getting through their committee processes and stuff like that.
Okay, perfect. Hardest lesson you've learned as you've been part of building defense company?
Yeah, the under pressure thing is an interesting one. The cultural aspect, being an Australian in the US, like Australians have a reputation of being sharp and pretty dry in their application of humor, and I'm probably at the far end of that, even for an Australian. So sometimes I got to catch myself where like I'm making a joke, but everyone's looking at me like I just murdered someone's kitten. Some of that again, and it's those pressure situations because you just default to your fundamental behaviors when you're under the gun. So, a lot of the time I gotta find my inner American or find my inner Brit, depending on which room I'm in, and just kind of dial it back. Which is then sometimes why it's great to go home where I can just be full Shane. And that's sometimes nice as well. But that's definitely, I remind myself of that every day.
Number one piece of advice as you've seen leaders and you're a leader in building defense tech today, what would you recommend?
Yeah, I think the persistence and kind of being relentless on the mission side of things and not getting too distracted. So I think a lot of folks they'll get some bad advice from a small sliver of the customer community because their ability to access is sometimes limited. Go after something you've got conviction on and stay the course because you at the end of the day you don't want to have something that kind of comes out that's a homomobile that's kind of a mix of things. Try and find that niche that's different. Think through what are the competitors doing, both industrially but also the bad guys, and take a bet and just kind of have a bit of blind faith to kind of go after it with relentlessness. And the people who do that, and certainly for us, if we're looking for leaders or we're looking for companies to work with, that ability to kind of run through brick walls is incredibly valuable, as opposed to anyone who's being super compliant and easy to work with. That's not going to solve the problems that need to be solved. So.
Absolutely. Name a sacred cow in defense tech that will be proven false.
Yeah, that we can't scale. And I think, we're writing that story as we go. That the Silicon Valley, iteration approach doesn't apply to hardware. And that's right as well in its fundamental form, but in an applied form, I think it can work. So, the criticisms are there. We'll be judged on what we show. And, we'll keep pointing at the scoreboard for all the products we get in the field. So.
And the last one, what's the biggest opportunity you see in defense right now?
I mean, there is just so much going on in every aspect. Space is getting redefined right now. There's a bunch of interesting things going on. The close fight and Army is reinventing. So similar to when Loyal Wingman got started, Air Force was having a crisis of, purpose. There was never going to be another ACM activity because it was all, operating, doing coin type missions. Well, guess what? That's changed. There's a lot of talk around Army being irrelevant in the future fight, and that's just blatantly wrong. So there's a bunch of lessons coming out of Ukraine. I don't think they're all directly applicable to near peer with China, but there's some really interesting things on how to get mass effects into the battlefield. How do you then get the humans along with it in a highly denied space is going to be super interesting. And that's certainly a bunch of projects I'm working that aren't public right now, but they're going to be cool when they hit the streets. So.
Awesome. Well, you killed it, Shane. That was super fun. I could spend hours talking with you, and hopefully I'll be able to follow up with you in person and buy you a beer. But until that, we're going to have to wrap it up. But if people want to follow Anduril or, get in touch, with you guys? How best to do that?
Yeah, look, we're surprisingly active on social media. Like, if you've seen any of our founders, I think they're tweeting pretty much every day and they respond. So, there's certainly X for the founders, a bunch of the rest of us on LinkedIn. I spend a lot of time kind of talking to people asking for advice, finding good talent, stuff like that. So certainly to do that. And then obviously watch the website, watch YouTube. We're always pumping out new products with super cool marketing. It's one of the nice things here. Our marketing department's kind of next level. So, you'll see that on the Twitter sphere as well.
Well, that's great. Well, super fun conversation. I really enjoyed it, Shane. One of my favorite. I appreciate it, and let's keep in touch, and best of luck. You've got a cheerleader over here cheering for you guys, so it makes a difference to our country, our allies, and our warfighter. So appreciate all the work you're doing.
Cool. That was super fun. Thanks, Dave. Take care, mate.